Hello dear student, I am Professor Devashish Bose, Head Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 5th semester on the unit Forensic Toxicology Part 2, which has been jointly prepared by myself and Priyanka Pahade, PhD scholar, a UGC JRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Let's start our discussion with taking a look at what we are going to learn today. Today's lecture is been divided into 7 modules. Module 1, we will look on overview of duties and responsibilities of a forensic toxicologist. In Module 2, we will look at the function of a forensic toxicologist, that is analysis, sample selection, storage period, etc. etc. Then in Module 3, we will see functions of forensic toxicologist again in preview of analytical strategies, analytical methods, interpretation. Module 4, we will see ethics of forensic toxicologist. Module 5, limitation of a forensic toxicologist. Module 6, research in forensic toxicology. And finally, we will conclude and sum up our review. In present time, a forensic toxicologist has to perform a number of duties. In ancient time or during old age, these were involved to know the cause of death. Generally, a forensic toxicologist provides vital information to a clinical practitioner about possible drug overdose or accidental poison, suicidal drug taking, or to authorities investigating sudden drug death due to poisoning or due to any unknown substance which has been consumed by that particular person. Finally, the results of toxicological analysis assist the medical practitioner, coroners, and medical examiner in establishing the use of particular drug or discarding the use of that particular drug. Toxicology is also important in victim of crime. Drug may have been administered or given by an accused or suspect to the victim for reducing the consciousness. For example, in general, benzodiazepine is given in cases of sexual assaults. It is also important in workplace drug testing and human performance testing. The former includes detection of drugs of a persons at place of employment or work. Human performance includes to the detection of drug that might have increased the performance in various physical ability tests. Evidence generally used in this case is urine, but hair also plays a very important role and provide longer window of opportunity. Now we will see the 3 basic functions of modern time or modern day forensic toxicologist. Analysis. The main function is detection, identification, and frequently the quantification of drugs and chemicals present in the biological sample, which generally are obtained from human beings or living beings. Next is interpretation, giving opinion on the analytical finding for the presence of chemical or banned substance and as to the meaning of the presence of the detected substance and the effect of that drug and chemical may have produced on the victim or the abuser. Next is reporting. The presentation of the analytical results obtained from analysis either in written form such as laboratory reports or written report or as sworn in testimony at disposition or trial. What is the responsibility of a forensic toxicologist? A forensic toxicologist is a specially trained expert to examine the role of chemical substance and their adverse effect. The variety of potential adverse effect and the diversity of chemical present in our environment contribute to make toxicology a very broad field of science. Therefore, toxicologists are usually specialists to handle various areas of toxicology. The professional activities of toxicologists fall into 4 main categories, that is forensic, industrial, clinical and environmental toxicology, but could extend even up to occupational or workplace toxicology, wildlife toxicology, etc. Forensic toxicology emerged as the amalgam of analytical chemistry and fundamental toxicology and pharmacology. Forensic toxicologists are also primarily concerned with the medico-legal aspect of the harmful effect of chemicals on human and animals. The expertise of forensic toxicologists is primarily utilized in establishing the cause of death and elucidating its circumstances in post-mortem investigation. The work of forensic toxicologists is therefore considered as highly complicated, as a small amount of poison and their metabolites are to be isolated, purified and quantified from a highly complex matrix. Now we come to module number 2, Function of Forensic Toxicologist. Part 1, this is Analysis, Sample Selection, Storage Period. The analytical method employed for analysis generally depends on number of factors, such as volume or weight of sample and also on instrumental technique employed. So, it is crucial to choose proper toxicoanalytical method because forensic science deals with small sample size. The non-specialized initial tests in a series are variable for determining the presence or absence of a particular class of compounds. For example, color test or more specific thin layer chromatography to detect the presence of opium would give initial information about a drug class present. This would be followed by more specific test, that is instrumental method, which could be chromatography, spectroscopy, microscopy, etc. Analysis. The word analysis in this context should be considered to refer not only to the analytical method that will be used to detect substances, but also to several procedures that occur between the event of interest and the completion of the last analysis. The first activity of forensic toxicologist is sample handling, which refers to sample selection, identification, preservation and transmittal. Thus, proper sample handling is essential for obtaining accurate and precise results. The selection, collection and transmittal procedure all occur prior to the arrival of the samples in the forensic toxicology laboratory, whereas the preservation of samples begins with the collection and transmittal or transportage to the laboratory and continues until the sample has been discarded. The methods of analysis that are employed generally detect, identify and quantify the drug or chemical present in the biological sample, which depends upon both the analytical strategy employed by the laboratory as well as any specific evidence that may indicate to which drug or chemical substances the person may have been exposed to. All of these steps involved in the series of events that constitute the analysis from sample handling through to the final analysis must be conducted appropriately in order to ensure that the results are accurate. Analysis part should follow it. Information as much as possible concerning the case should be collected. Because limited amount of material is available for analysis, it is important to obtain as much information as possible. In addition to any witnesses, accounts or events, one must accurately record all relevant information as possible. While collecting the specimens, different body fluids and organs should be collected like blood, urine, saliva, hair, sweat, buccal sap for knowing the cause of death. Specimens should be collected according to the collection procedure because different samples have different collection procedure. Blood should be centrifuged and plasma should be sent in frozen condition. The minimum amount should be around 5 to 10 ml and sent laboratory in refrigerated condition. If blood is in dry condition, so it is necessary that it should be air dried in shadow and then packed in paper. Samples which are not degradable like hair, nails, soil, etc. be preserved in paper envelope with druggist fold or polythene that can be used. If articles which are small in size and carry physical evidence, it would be necessary to pack and send to laboratory without removing evidence from that article. Every sample should be properly labeled, sealed when they are being forwarded to the laboratory for analysis. It is also possible to collect useful specimens from burned or burial remains. The tissue often collected under these circumstances include bone marrow, skeletal muscles, vitreous humor, hair and maggots. For example, from hair sample, it is possible to detect the presence of antibiotics, antipsychotics and other drugs of abuse. However, the information is primarily qualitative in nature. It is from maggots, barbiturate, benzodiazepines, phenothiazines, morphines and even malathion can be detected. It is often necessary to add preservative to specimens to protect against post-mortem changes. Sample selection. The post-mortem toxicologists have the ability to select samples required for the initial analysis and any reanalysis from all body except when the desired sample had been destroyed, that is in condition of putrefaction. Generally, in other areas of forensic toxicology, that is, in the case of living being, the samples that are available for analysis are limited, usually to blood, urine, saliva, swab, vomit, fecal material, nails and hairs. With the exception of sample preservation, forensic toxicologists generally are not directly involved in sample handling. However, they should be involved in establishing procedure for samples that will be necessary for the analysis and interpretation of results are selected, collected and transmitted in appropriate manner. An ideal sample is one that allows ease of analysis with accurate result that may be interpreted to provide the required information. For example, the only information required is if the subject used a specific drug, then urine may be the sample of choice. However, if it is necessary to know the type of effect that a drug had on a subject or to that person, then blood generally would be the preferred sample. If the ideal sample are not available, then the collection and subsequent analysis of the so-called alternative sample or alternative matrix, those not usually collected and analyzed, may be appropriate since the analysis of these samples may provide the desired information. Storage period. Forensic toxicologists conduct analysis of sample that may have been stored from different period of time. Ideally, there would be no change in the sample matrix or concentration of analyte as a result of these storage periods. However, as a result of the duration and condition of sample storage, analyte concentration may be altered. Obviously, if any such alteration occurs, the interpretation of the analytical results become problematic. Therefore, forensic toxicologists must be aware of the changes that can occur during the storage phase and take appropriate action when the sample are in their possession to minimize the alteration. The first storage period occurs between the time of the event and the time of sample collection. This period may be hours or days. During this storage period, drugs and chemicals may undergo metabolism, degradation or redistribution from one anatomical site to another. Often, as a result of these events, the alteration of analyte concentration that can occur and cause error in interpretation also. However, they must also be aware of the event that can alter drug concentration and the factors such as heat, humidity and putrefaction. The second storage period, the time between the collection and the initial analysis of the sample, usually is hours, days or even weeks in duration. During this period, the concentration of drugs and chemicals in the sample may also be altered as a result of continuing metabolism activity, degradation or redistribution within the sample. This storage period has two temporal components. The first is the transportation time between the collection of the sample and their arrival to the forensic toxicology laboratory, and the second is the time period between the arrival of the samples and the forensic toxicology laboratory for their analysis. During the transportation of the samples to the forensic toxicology laboratory, the samples are in the custody of persons, laboratory technicians and police officers who or other staff should be trained to employ appropriate method so that any alteration of drug concentration, if any, may be minimized. The third storage period, a long time storage of sample, is necessary for future need, either to repeat certain analysis because the results of the original analysis have been changed, or to conduct additional analysis. Because the continuing investigation has suggested the involvement of drugs or chemicals not considered at the time of the original analysis. Generally, samples placed into long-term storage are those in which one or more drugs or exogenous chemicals have been detected. However, the most common method of preservation of samples during this period is by freezing at generally decreased temperature. From the time of their collection, throughout the 3 storage periods, sample must be handled in such a manner that not only the scientific integrity but also the legal integrity of the sample is maintained. Now we come to module 3, function of forensic toxicologist, second part, analytical strategies, analytical methods and interpretation. What is analytical strategies? Generally, the specific methods of analysis used by forensic toxicologists may vary widely. The commonly accepted analytical strategies consist of 2 types of analysis. The first is a presumptive or screening or preliminary test designed to identify samples that do not require further analysis until the analyte of interest is not detected. Generally, the methods employed for preliminary analysis have very low detection limits but are easy to perform, inexpensive and compatible with rapid batch analysis. The second analytical strategy contains confirmatory or secondary methods that is used for the analysis of those samples in which one or more analytes have been preliminarily identified. Confirmatory tests are more specific than the presumptive test and ideally have detection limits that are equal to or less than those of the presumptive test. Positive results are reported only if both the presumptive and confirmatory tests are positive. For example, for blood analysis, preliminary tests include color test and secondary or confirmatory tests include microcrystal test and instrumental method. Next is analytical method. The work of forensic toxicologists is to detect, identify and often quantify the drug and chemicals in ante and postmortem exhibits or sample. For this purpose, forensic toxicologists have to be a competent analytical chemist who should be knowledgeable about the modern methods of immunological and instrumental analysis. Generally, forensic toxicologists counter problems related to the sample that they are going to analyze. Example, interference from post-mortem putrefacitive products, alteration in concentration of drugs due to their post-mortem degradation, detecting of sub-microgram quantities of drugs in extremely complex matrix such as liver or brain. They have developed new methods and modified existing methods. In practice, due to the complexity and sophistication of modern analytical methods, no forensic toxicologist possesses nor should be expected to possess expertise in all methods that have an application in forensic toxicology. However, they should possess a thorough understanding of the theory and practical aspect of the methods that they use on a regular basis. Interpretation. Analysis by forensic toxicologists are performed to answer many varied and wide-ranging questions such as: was the sudden death of a 75-year-old man in his bedroom was due to an overdose of sildenafil? Was the driver of a car involved in an automobile accident was under the influence of any drug? Does the detection of marijuana metabolite in the urine of a 30-year-old indicate recent use of marijuana? The answers to these and numerous other questions are not based on analytical results alone, but rather in the consideration of oral evidence obtained from police investigation, medical history, eyewitness, testimony, and autopsy finding. Additional consideration must be taken into the evidence pertaining to a specific subject, including gender, age, existing pathology, tolerance, and post-mortem redistribution on all factors that may influence the interpretation of analytical results. For accurate analytical results, forensic toxicologists must have knowledge about the concept of pharmacology, biochemistry, physiology, and pathology, and especially an understanding of the event of drug absorption, distribution, metabolism, excretion, the rates at which they occur. It is most likely that forensic toxicology will be able to provide reliable answers to questions when both accurate analytical results and relevant evidence are available. It is important to note, however, that forensic toxicologists must not make interpretations or draw conclusions that are out of the purview of their expertise. This includes conclusion opining as to the cause of death, since toxicology results are only one piece of information in a cause of death. Dear student, now we come to module 4, that is ethics of a forensic toxicologist. The ethical behavior of forensic toxicologists and all other forensic scientists must be of the highest order. They must not have a dispute opinion in legal cases in which they are involved and must function as disinterested third parties who have neither a professional nor personal interest in the results they obtain. Forensic toxicologists must not have an opinion about either the guilt or innocence of a defendant in a criminal case or the outcome of a civil case. Their only concern and responsibility is to provide an accurate and objective report of finding and interpretation that will assist the jury in arriving at a decision. The behavior that is appropriate for forensic scientists generally and forensic toxicologists specifically has been codified by several regional, national, and international professional organizations. Forensic toxicologists should maintain confidentiality about their work and not divulge either the name or personal information of person from whom samples have been obtained or the results of any analysis. These ethical requirements apply not only to forensic toxicologists employed by government agencies, but also to the many forensic toxicologists who are employed in private laboratories and those who are independent consultants. An additional and extremely important structure for non-government scientists is that any fees that they receive for these services must be independent of their finding. Now we come to module number 5, limitations of a forensic toxicologist. Chain of custody in forensic science is very important, with elements such as sample collection, processing, handling time, and all involve personnel. Due to lacuna of single step, it may interfere with result. A most stressful factor to the forensic toxicologist is the limitation of sample size, which may impact the number of tests that could be performed and reproduced with an acceptable degree of certainty. Procedures used in forensic science are very significant, as it is critical to document details on analytical methodologies such as instrumentation, sensitivity, and specificity. A new challenge is increased amount of new synthetic or designer drugs and herbal products or its isolated chemical ingredients which are abused or utilized to facilitate crime, and these products are emerging each day. So, detection is cumbersome. Now we come to module number 6, Research in Forensic Toxicology. In addition to the case related to the duties of analysis, interpretation and reporting, forensic toxicologists also involve themselves in research related to their work. Traditionally, forensic toxicologist research has considered largely of the development and application of analytical methods or case reports of the drug and chemical substance that have been determined in various post-mortem tissue and fluids. Method development and application are of obvious importance, and over the past half century have led to meaningful advances in both the sensitivity and specificity of analytical methodology in forensic toxicology. A vision of future research in forensic toxicology may be seen in the recommendation of the Scientific Working Group for Forensic Toxicologists, which has proposed several specific priority research areas in forensic toxicology, including chemical terrorism, drug interaction, emerging drugs of abuse, nanotechnology, population-based toxicology, example, sex, race, disease states, pregnancy, elderly, pediatric, toxic concentration ranges, pharmacodynamics, toxicodynamics, pharmacokinetics, toxicokinetics, pharmacogenetics and pharmacogenomics. As these proposed research areas demonstrate, it is necessary that forensic toxicologists are knowledgeable in areas other than analytical and instrumental analysis. With this module, we come to the conclusion, that is module 7. This chapter highlights the role and responsibilities of forensic toxicologists, their limitations, as well as how should be sample collected and what precautions should be taken while sample collection. What should be the ethics of a forensic toxicologist when they are working in laboratory, and so on. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. It's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge on this topic, you may log on to our website for MCQs, quizzes, LORs at www.cec.nic.in. Till then, thank you and goodbye.